Today we will discuss about some concepts related to chemical reactions. Now, when we consider the general reaction here, suppose it is reactant. In presence of some reagent and different condition, and it react with C. It gives product AC and B is side product. This is main product. Means what happened in case of chemical reaction? There are breaking and making of bond, making of new bond. So for this we will discuss today cleavage of bond. Cleavage of bond. Cleavage of bond. Now you know very well about this. Covalent bond is made from sharing pairing of electrons. Sharing pairing of electrons. And there are two ways to break this bond, and on the basis of this there are two types of cleavage of bond, that is homologic cleavage, that is called as homolysis, and heterolysis. And what happens in case of homolysis? These shared paired bond electrons are distributed equally and form free radicals But this is happen only in that case where the both atoms are same here. Suppose chlorine molecule as well as hydrogen molecule. Now, but in case of heterolysis, suppose B is electronegative in nature, and this is electropositive in nature. Then here distribution of this bond pair electrons unequally, and this bond pair of electrons are moved towards electronegative element, and it forms negatively charged species, and those are electropositive nature, it acquired positive charge. Then it is called as cation, and this is called as anion. but this is happen only due to the unequal distribution of bond pair of electrons. Now, this cleavage of bonds we will see with the carbon containing compound. Now, suppose you take the example, general example, cleavage of bond in between carbon single bond. Now here, suppose these electrons are equally distributed, then it forms carbon containing odd pair of electrons, and this is called as carbon free radical. Carbon free radical. Now, suppose this distribution of bond pair of electrons unequally means so this bond pair are shifted towards one carbon atom due to the different substituents are attached. Here, one carbon atom carries positive charge and another carbon atom carries negative charge. Those carbon atom carry positive charge is called as carbocation, and those carbon carry negative charge is called carbanion. It's called as carbanion. Means unequal distribution or heterolysis generate a carbocation and carbanion, but equal distribution or homolysis it gives carbon free radical. And generally this carbon free radical and carbocation as well as carbanion is called as reaction intermediate. Okay, now we will move towards the reactivity. Now here, for reactivity, we discuss the one example. Reactivity of molecule. For this, we will discuss one name reaction, that is Aldol condensation. Aldol condensation is the reaction of two molecules of aldehyde or ketone in presence of base and gives here aldol is the product, because here aldehyde group is present as well as hydroxyl group is also present. Now, for this reactivity of molecule, we consider the mechanism of this aldol condensation here. Now, you know very well about this base catalyzed reaction, and here main condition is that alpha hydrogen is required for this reaction, and in presence of base. Now what happened here? Now what is the relation in between this reactivity and the effect, different effects? Now here C double bond O, this group shows minus R as well as minus I effect, and due to this carbon carry partial positive charge and this alpha carbon carry partial positive charge, and you know this hydrogen having already electropositive nature, and due to this bond become weak bond, and this is the good side for this hydroxy group is attack on this hydrogen and it form the carbanion. Side product is water molecule here, and now this is conjugate base. This is conjugate base, and here this conjugate base is resonance stabilized. Conjugate base is resonance stabilized, means removal of hydrogen is depending upon the or related to minus R as well as minus I effect of CO, and this concept or this phenomenon is nothing but the reactivity of molecule. When suppose you consider here this base is react with propane molecule, then there are no reaction because there are no any particular site or acidic proton like this acetaldehyde to attack these OH minus ions. Means in this case no minus I and minus R effect, and hence any particular molecule become active in any particular reaction is depending upon the different structural effect. Now for the explanation we consider the second step of this aldol condensation. Now here second molecule of acetaldehyde is react with carbanion. This is carbanion. Now again due to the minus I and minus R effect, this carbon atom become electron deficient, and hence this carbanion are attack on this carbonyl carbon, not on this carbon atom, because this carbon atom is more electron deficient as compared to this one, and hence this is attack on this carbon atom, and this is the reactivity of molecule on the basis of this different structural effect like minus I and minus R, and there are new bond is formed CH2 silver bond O H, and this is new carbon bond here, and we complete this reaction and it gives the aldol product. Means the reactivity is depending upon the structure of the molecule, and structure gives the idea about which site is active for carbanion, or suppose you consider another intermediate or another reaction intermediate, means the depending the reaction reactivity is depending or with this minus I, minus R, as well as steric effect, hyperconjugate effect, etc. Now last point related to this reactivity is nucleophile and electrophile. Electrophile is nothing but the electron rich species. Nucleophile is electron rich species. Electron rich species. We take the example here. OH minus, Cn minus, then ammonia, water. Now when consider these examples, generally all these species having the lone pair of electrons, and hence they are electron rich and they donate the electron to another species. Now when we see the types of nucleophile, there are two types of nucleophile. One is charged nucleophile and some are neutral nucleophile. Neutral nucleophile, and this nucleophile is symbolized by Nu. Now here when this nucleophile donate their lone pair to acid, then this is called as Lewis base. Not all nucleophiles are Lewis base, but those nucleophiles donate the lone pair of electrons to H plus or acid, it is called as Lewis base. Means some nucleophiles act as a Lewis base. Okay. Then electrophile. Electrophile is electron deficient species. Electron deficient species. Now we take some example here. Like CS3 plus, Br plus, NO2 plus, BF3, AlCl3. Again, like nucleophile, there are two types of electrophile. Some are charged nucleophile and some are neutral nucleophiles. Means here these are charged electrophile and some are neutral electrophile, and sometimes this is called as Lewis acid because they accept the lone pair of electrons, and hence sometimes this electrophile is named as Lewis acid. And these nucleophile as well as electrophile all are the different reagents for the different reactions. So nucleophile and electrophile are the main initiator of the reactions. Thank you.